Hi guys, welcome to our lesson for today. So today we're going to be looking at solving circle geometry riders, right? Just to quickly explain what riders are, these are just questions that involve a combination of the theorems that we've done under circle geometry. So it's not a new concept, it's just how we call the questions that we solve under circle geometry. So please don't now be thinking it's something that you need to think about and try to solve. No. It's just questions that involve a combination of these theorems. But for now, let's just look at what we need to do for today. So firstly, we know that when it comes to circle geometry, I like it when we separate this based on lines and angles and then cyclic quad, because cyclic quad comes from lines. And then you can talk about the theorems that are involved in having lines, right? Which will be a radius, perpendicularness, a chord, a tangent, and then you can link all of those to theorems. But now we will actually be linking them while trying to solve the questions. Now, hints for solving these riders. Firstly, you need to make sure that you mark all the given information on the diagram. So for example, when they tell you that in triangle ABC, line AC is equals to AB, as soon as they say that, you quickly go to your diagram and draw a line by AC and AB to show that they are equal to each other, if those are the lines that they are saying are equal, right? And then from there, you then identify how the information links to the theorems available. Now that I have a triangle which has two sides being equal, it then means that the angle C and angle B will be equal to each other. And that theorem has to do with properties of an isosceles triangle, right? So you would then say its angles opposite equal sides. So this is, excuse me, something that they tell you although they don't tell you. So it's like an implicit information that they are suggesting, but you must know it based on the information they have given you. And then from there, I'm saying one more example will be if maybe they tell you that a line is a tangent. This can be linked to a tangent chord theorem when an angle is equals to an angle in the alternate segment. You know how tangent chord theorem looks like. And then also you can think about tangents from the same external point and more, right? One more, I think, property there will be a tangent perpendicular to the radius. So those are just the things I want you to think about. So I don't want you guys to then quickly rush to the questions as soon as you read the statement. No, you read the statement, try and mark those things on your diagram, and then mark additional information that is there based on the markings that you've done because of the given information, right? So this is you thinking about, what does a center tell you? What does a line being equal to that line tell you? What does a tangent tell you? What is implied by saying this is a cyclic quadrilateral? So those are questions that you need to be asking yourself. That's what I mean when I say then include your additional information, right? So please make sure you are clear on that. And then the other thing that you will need to do will be to mark this additional information that is linked to these theorems as I showed you with my triangle there. Then from there you quickly go to the questions. You construct a short direct argument. What I mean by this is you guys normally have a list of things that you are mentioning that have nothing to do with what we want you to solve. So you always need to be sure that when I want you to talk about an angle in this triangle, you specifically focus on this triangle. And that will be your short direct argument. And then please remember, when it comes to geometry, monkey see, monkey do does not apply. So because it looks like it, you cannot claim that it is it, right? So it means I must tell you, so you must give me reasons each time. Now let's try and apply all of this into a question. It says here, O is the center of the circle. Already, that's important for me. I am pausing there. Now, about a center, I know that I can think about the radius of the circle. I can think about the angle at the center. I can think about a line passing through the center, which will give me a diameter, and then a semicircle, then a 90-degree angle. You see, so already I'm thinking about those things before I can even go to my questions. I know that A, B, C, D, and E are all points on the circumference, so meaning there might be a cyclic quadrilateral that we're going to think about in terms of this when we group 4 points that lie on the circumference if they form a quadrilateral. Then chords B, E, and C, D produced meet at F. The importance of me saying that these lines are produced is to tell you that you can now think about an exterior angle of either a triangle or of a cyclic quadrilateral, depending on which line is produced. Is it in a triangle or is it in a quadrilateral, right? So that's not just me telling you additional information. No, it's important that I inform you that the lines produced, it simply tells us also, maybe if we were to explain this, right? This means that the line is extended, right? The line is extended. So you extend a line. That's what it means to produce a line. Then angle C is 100 degrees, angle F is 35, and AEB is 55 degrees. So let's look at our diagram and add some additional information that we might know based on this, right? So what exactly do I know here? I know that O is the center of the circle, making the angle A to be 90 degrees. I will give a reason, right? This is a semicircle, right? Angle in a semicircle. Already I know that, right? Based on that, I also know that I can talk about angle E1. If I add it to angle C there, it must give me 180 degrees because this is opposite angles of a cyclic quad. Opposite angles of a cyclic quad are supplementary to each other. You see, so all of this is additional information that I am linking on the theorems that I know based on the given information. First question, we must find the value of A. Immediately, you saw in the previous one that A was already there, which is 90 degrees. Now you just need to state it and give me a reason why you say that is the case, right? So you can see that angle A here will be equals to 90 degrees, and my reason for this will be angles in a semicircle. Right, angle in a semicircle. Some people prefer saying angle subtended by a diameter, angle opposite a diameter on the circumference. It's really up to you. But as long as you talk about the fact that it's a diameter that's subtending an angle on the circumference, then you can claim that A is 90 degrees. But the actual acceptable reason that we normally use is angles in a semicircle. That will be the 90 degrees, right? And then we also want the value of E1. To find E1, as I said, E1, if I was to maybe highlight this, right, you guys will be using your colors. So quadrilateral BCDE is a cyclic quadrilateral, making E1 and C to be supplementary because they are opposite to one another. Therefore, that will make E1 to be equals to 180 degrees minus 100 degrees, and then your reason will be opposite angles of a cyclic quad. Angles of a cyclic quad. Please just remember that CQ means cyclic quad, right? Hence, I'm using the short version of how we normally say this in geometry. And then you will solve. your value will be 80 degrees. Now, some people always want to include a reason there. You can't include a reason there because you just applied algebra. So you don't need a reason for 180 degrees minus 100 is equals to 80 degrees. That's just math, right? You only need a reason for something that you claim that we wouldn't have said or that we wouldn't have told you, and then give a reason why you are claiming it. The other angle we need to find is angle D1. So before we can even go to D1, we firstly need to look at where is D1, right? So D1, you can see that this is in triangle FED, right? Or some people say DEF if you follow the alphabets in terms of the alphabetical order, right? Now, for me to find D1, it means I must know what B2 is. Because if I know B2, then I can talk about an exterior angle of a cyclic quad. That's one option. Or I can find what E2 is, which I already know because of E1, and then use sum of angles in a triangle. So it's an either or situation that you can do with this, right? So that's one way that you can do. But I think the second way will be the short one, because to find B2, I will use sum of angles in a triangle BCF, and then use that to find D1. Or I can find first E2 using angles on a straight line, and then find D1 using that. So either or, it's really up to you. So maybe let me take maybe the first method. So to find B, I will say B2 is equals to 180 degrees minus, right, 100 degrees minus 35 degrees. Minus 35 degrees. And then you will then subtract accordingly based on that, right? Whatever value you get here, it will be equal to the same value as that D1 there. So this will simply be, my reason, by the way, is sum of angles in a triangle. Because remember, I need a reason every time. 180 minus 100 is 80, minus 35 will then give me 45 degrees. So therefore, you will then say D1 is equals to 45 degrees, and your reason will be exterior angle of a cyclic quad. And that's how you can then do that, right? So you need to make sure that you understand first, what did I give you? Based on what I gave you, you link it to the theorems that you already have knowledge of, and then mark all of those things on the diagram, and then go to the questions, and you'll be able to solve the questions. Guys, I want us to take a quick ad break. When we come back, we'll look at some more questions where we're going to apply all these theorems that we already know in terms of circle geometry. Please stay tuned. I'll be back just now.